All right, welcome to the second half of those solving equations and notes packets. We've got 5 slides we want to get through here, and I'm going to try and get through all of them in just one video. So solve for x by factoring out the lowest power. Now, when we're talking about factoring out the lowest power, what you want to be taking out is the smallest value with the negatives. And then again, still the smallest value with the positives, but the positives you're sort of used to. So looking at this, I have two terms. If I'm looking at the coefficients 2 and 3, I can't take anything out of those. When I look at x to the negative third and x to the negative fourth, you want to factor out the lowest power, just like we would with the positives. So I'm going to factor out x to the negative fourth. Then with the x minus 3's, we have x minus 3 to the first, x minus 3 to the second. Just like always, what you're looking for is what you can take out of both of those. So that would be 1 of the x minus 3's. Sort of that lowest power still. What you put here is what you're left over with then. So I'm going to have this 2. To explain what's going to happen here, I'm just going to go over here and say, when you have x to the negative third, what we're doing when we're taking something out is we're factoring it out, so we're really dividing it out. So this is what we're doing in order to get this term. Our property of exponents say that if we have division, what we do is subtract. So this is x to the negative third minus negative fourth. That minus negative becomes plus, so this is just x to the first. So over here, where I took x to the negative fourth out of x to the negative third, I'm left with x. I took out the x minus 3. Now I bring down my minus. I have a 3. I took out all of the x to the negative fourths, and I took out one of the x minus 3's, so I have one left over. I need to simplify this factor then. So I get 2x minus 3x plus 9, which is going to give me negative x plus 9. So this is my last factor. Keep in mind, this question is an equation. So I'm not doing a sign analysis chart with this. I'm looking for where is it equal to 0. It's sort of like that first part of the sign analysis where you find those zeros. Here, my 0 would be 9. Here, my 0 would be 3. And here, thinking about what x to the negative fourth really is, that's 1 over x to the fourth power. 1 over x to the fourth power, even if I put 0 in here, isn't going to be 0. That would make this undefined. So this does not have its own solution to have something be equal to 0. So we'd have just x is equal to 3 and 9. This is just our set brackets, sort of squiggly lines. All right, moving to some more of that. Solve for x again, factoring out lowest power. So if I'm looking at these two, the coefficients 1 and 5, I can't take anything out from there. I want to take out the smallest exponent. So I want to take out x to the positive 2/3. What I'm left with then, keep in mind, if you're taking x to the 2/3 out of x to the 2/3, it doesn't just disappear, it becomes 1. Minus, we know we'll have that 5. And again, x to the 5/3 and x to the 2/3. What you're doing is x to the 5/3 over x to the 2/3, which means you'd be subtracting 5/3 minus 2/3, which gives me 3/3, which is 1. So this is x to the first power. Now I set each of these equal to 0. X to the 2/3, if you're thinking about what that is, that's the cubic root of x squared. The cubic root of x squared, or just x to the 2/3, zeroes out at 0. 1 minus 5x, if you wanted, you can set this equal to 0 and solve. So we're going to get 1 equals 5x. So x equals 1/5. So we have x is equal to 0 and 1/5. Again, those sort of set brackets to show that it's the set of those two numbers. All right, just some more examples. Again, just plowing through all these examples. Looking at this, I could take out x to the negative 1/2 from these two terms. When I take x to the negative 1/2 out of x to the positive 1/2, I'm left with just x. Again, think about this is 1/2 minus negative 1/2, which would give me a positive 1, minus 4. I took out all of the x to the negative 1/2 equal to 0. So here I get x equals 4. Here, thinking about what this really is, the negative says this is 1 over. X to the 1/2 means square root x. And 1 over square root x, or 1 over anything, could never be 0. So that has no solution. Our answer here is just x equals 4. All right, and then moving into a little bit tougher ones, solve for x by factoring out the lower power. So what I want to do for these ones is first start by rewriting these so that all these roots are rewritten as exponents. So I'm going to start with the easier one. If I have square root x, that's the same as x to the positive 1/2. Over here, this is 1/2 x plus 3. And then what I want to rewrite is the square root x, but I want it to be in the denominator. So this is like 1/2 x plus 3 x. 1/2 makes it a square root. Negative puts it in the denominator. Now you should sort of reorganize this. It should be 1/2 x to the negative 1/2 x plus 3 plus x to the 1/2 equals 0. And all this allows us to do is now sort of more easily see those powers. So now looking at just these two terms, I want to take out the lowest power, so that's x to the negative 1/2. What I'm left with then is 1/2 x plus 3 plus, if I take out x to the negative 1/2 from x to the positive 1/2, I'm left with x. I simplify this then, so I get 1/2 x plus 3/2 plus x. And if I combine these, I get 3/2 x plus 3/2 equals 0. So x equals negative 1. Here, again, that's the same as 1 over square root x, which is never equal to 0, so there's no solution to that factor. So you would want to be like, oh, okay, so x is equal to negative 1/2. But no, because this problem implicitly has a domain restriction. The domain for this is that x must be greater than 0. It can't be equal to 0, because if I had it equal to 0, then I'd have undefined over here. It can't be negative because I can't square root a negative. So x equaling negative 1, algebraically everything's right, but we can't include it because of the domain restriction. I'll write that down there just so that you have that term sort of remember. If we go back to any of the previous problems that we just did, here we had domain restrictions as well. This is square root x. This is 1 over square root x. So the domain of this x must be positive. Couldn't be 0 because of this one. Didn't matter here. Here, you're taking cubic roots. You can cubic root every number. So I don't have to worry about a domain here. In this case, the only thing that x could not be, because this is like 1 over x to the 4th, our domain here is that x could not be 0. So let's start in this problem by talking about domain. Looking at this problem, I've got two terms, and what I want to look at is the individual factors of them. So first, let's actually factor it a little bit. Well, no, let's just deal with it right away. 4x minus 3 to the negative first. What that is 1 over 4x minus 3. So the only issue I have with 1 over 4x minus 3 is that the denominator cannot be 0. So in this case, x cannot be equal to 3/4. If you were to set this equal, to 0, you would get 3/4. So x cannot be 3/4. We also have 1 over x minus 7, which tells us that x could not be 7. So we just want to keep that in mind as we're going through these problems, because if we algebraically get them as answers, we'd have to exclude them and say, nope, actually that doesn't work. All right, so now let's deal with the factoring. Looking at the coefficients, you could take out a negative, but you don't exactly have to take out the negative. Sometimes it's helpful, but I'm going to leave it. Looking at the 4x minus 3's, I have -2 and -1. I take out the lower one, -2. Looking at the x minus 7's, I have -5 and -6. I take out the lower one, -6. Then I look at each term and I talk about what's left over. This -4 is left over. I took out both of my 4x minus 3's. I'd have one x minus 7 left because I'm taking -5 minus -6, which gives me a +1. -5. I took out all, -6 of the x minus 7's, but I would still have a 4x minus 3. Then I simplify everything inside here. -4x plus 28 minus 20x plus 15. So combine, I get -24x plus 43. And set this equal to 0 to solve. You get x is equal to positive 43/24. Over here, this is 1 over x minus 7. I want to know when it's equal to 0. It's never equal to 0. This is 1 over x minus 7 to the 6th power, is 1 over 4x minus 3 squared. I want to know when is this equal to 0. 1 over nothing will ever give me 0, regardless of the fact that this is squared or the fact that this is to the 6th. 1 over nothing gives me 0, so no solution there. So my only solution will be 43/24. All right, not that bad, just a lot of practice with that factoring, especially the factoring with negatives, fractions, and especially pay attention to the idea of how to rewrite some of these. It's an important topic as well. Get started on some of those worksheets, make sure that you're checking those answers and checking solutions if you have them.